Please help me in welcoming Alex Roy to the stage.
Hi, my name is Alex Roy, and I'm thrilled to be here because I never endorse products. Most products are junk, and they never really do what they're supposed to do. But when I was 15 years old, I saw the movie Predator, and I was very impressed with the thermal camera capabilities of the Predator. And so years later, when I, for no damn good reason, decided I would become a street racer, an underground driver, I knew that I would require a thermal camera on my car. Because in the history of cannonball run racing, there are many mythologies. Mythologies of people using spotter planes and having two cars and police scanners and radar detectors. But the one mythology which really grabbed me was putting a thermal camera on a car. Because if you want to drive cross-country at 140 miles an hour for 30 to 35 hours, you need every single safety technology you can get your hands on. So in 2001, I began poking around to see where I could get my hands on a camera, and I learned of FLIR. So I sent an email, and no one responded. So I went on eBay and found a salvaged FLIR camera and installed it on my car. And 3 attempts and 2 years later, we broke the Cannonball Run record, driving cross-country in 31 hours and 4 minutes. And after many years of emailing FLIR, I finally got their attention. And I got the attention of a man named Paul Clayton, which we will now invite out now. Paul, please come out. Thank you, Paul. So, Paul was kind enough to look past my criminal past and ask to discuss what I thought the future of thermal cameras could possibly be, because the market is obviously much bigger than the 75 people who still go out every year to commit crimes on our roads. The future lies in thermal cameras making human driving safer and self-driving vehicles safer. Paul, please sit down.
Yep, thanks.
Because now we have Stuart Klapper from Veoneer. Hello, Stuart. Stuart, who is the next leg of the tripod of companies working to make human driving and self-driving cars safer. Stuart disapproves of my presence here, but agrees that there is no better ambassador for this product. Thank you, Stuart. And Sandeep Sovani from Ansys is the third leg of the tripod, delivering this technology to the world. Now, I stress again, I never endorse products, ever. But FLIR is something that I actually paid for out of my own pocket. And FLIR was kind enough to invite me here to have a conversation about why thermal cameras are the next generation sensor, not just as ADAS, but for self-driving vehicles. I've been wondering for years why thermal cameras are not ubiquitous in the sector. So let's start this way. Paul, what is your role at FLIR?
My role at FLIR is I'm the general manager of the facility in Goleta. If you look at all the thermal solutions we have here in the booth today, I actually am in charge of making all of those thermal cores. We sell them to internal verticals, which you see, and also we sell to other OEMs to integrate into their solutions. So yeah, we're the thermal driver for FLIR.
Now, Stuart, Veoneer, what is your role in FLIR? Like, are you explain to me how you sell this stuff?
Okay, well, I work for Veoneer. It's the world's largest supplier and it has the largest portfolio of electronic safety equipment for cars. And I spent my whole career trying to put infrared in cars. When infrared was so big, you could barely put it in the trunk of a car. I tried to figure out how to make it smaller and better and useful on cars. So I was responsible for the very first implementation of thermal in cars. So today I'm now responsible for global marketing for our company.
Okay, and Sandeep, what does Ansys do in the chain of getting FLIR onto the roads?
So Ansys does something really exciting. It's called simulation, and we simulate products, engineering products, to give insights into how they're going to behave. We help companies like FLIR develop their sensors in a virtual environment in a much, much faster life cycle than would be done in physical prototyping.
All right, now let's go back in time, because when I was trying to get my hold on a FLIR camera, it was almost impossible. I mean, I couldn't just call up a distributor and say, I want to buy a thermal camera back in 2000. So my understanding is that FLIR was primarily a military supplier. Is that correct?
At the time, yes, it was.
Walk me through FLIR's history from inception through the early 2000s.
FLIR started supplying the military, law enforcement, primarily for detection of people, bad people, and to support our mission of saving lives and livelihoods. As it's evolved and the market has adapted to seeing the value of thermal outside of military, we're now looking for search and rescue. We now can help firemen go into a building and look through smoke and save people. And so there's so many applications for thermal that it's expanded way past military. And today, FLIR is actually a larger commercial business than it is actually a military business.
Stuart, explain to me the history of you trying to get thermal cameras actually into cars in the marketplace. Because it seems very obvious to me that it is impossible to drive a car safely, for a human driver, to drive a car safely without a thermal camera on the dashboard. Why aren't they ubiquitous?
Yeah, well, it started, our relationship with FLIR started in around 2002. And at that time, we were part of a company called Autoliv, which was the largest automotive safety supplier in the world. And we started to work with FLIR, and we tried to figure out how to take their technology and put them on cars. So the very first car we put it on was a BMW, which got launched in around 2005 timeframe.
Now, I had a list of questions pertaining to how to get away with committing crimes in cars and how often people buy such cameras to rob banks and drive fast, but apparently these questions have been rejected. They really want me to ask you why thermal cameras are not part of the traditional ADAS suite. Why?
Well, primarily it's been the cost of thermal technology. Remember, when it was first used for military application, the systems were $100,000 and more. And
What year was that?
That was in the 80s and early 90s. And so finally, when it started to get smaller and lower cost, the technology was eventually capable of being put into cars. So we had to start in luxury cars like BMWs. So we started there, and as the volume increases, and over time, we will start to see them in every car.
So the unit that I bought in 2004 was probably $3,000 or $4,000, I think. And so a unit like that would have fallen to what, a Generation 1 unit. What does that cost today?
Today, that kind of a system.
Oh, that kind of capability.
That kind of capability is a tenth that price almost.
And Paul, you wouldn't let me show the video of me using it, but let me tell you, at 135 miles an hour, it is a very effective method of spotting animals and pedestrians. But we'll get to that.
Yep.
Now, in terms of safety, walk me through what kind of safety improvements one gets when you add a thermal camera. I mean, everybody knows there's 41,000 people killed a year, or 40,000. But I mean, how many vehicles on the road? What is the penetration of thermal cameras up till now?
There's around 600,000 thermal cameras in cars today. And as you can see from this graphic here, there's about 75% of pedestrian fatalities occur at night. And we had almost 6,000 fatalities last year. So it's really important. Who wants to own a car, drive it at night, and hit a pedestrian? If you think about it, it's the kind of thing that will ruin your life. Not only do you have the guilt of hitting a pedestrian, but then there's all the legal expenses of going, of the fact that you've hit a pedestrian. It's something you definitely don't want to happen to you.
I'm just curious, though, the camera that I bought today can be purchased for 90% less? Literally 90% in 12 years.
It depends on the volume. It depends on the volume, of course.
Thanks. All right, let's move on to the next question, which I did not come up with, because all I want to do is talk about the cannonball. However, there are who's got the clicker? This is the scene from the accident location. Is this not the Elaine Hertzberg video?
So what this is everyone's familiar with the Uber situation that happened in Tempe. And we took a car, and we actually reproduced the exact same kind of conditions, and you can see the person here detecting it. So what you're actually seeing here is we reproduced the time of day, the field of view. We put visible next to thermal. If you could play that again, if you could back up real quick. First of all, you see a lot more situational awareness with thermal at night, but the main thing is the car was traveling at 43 miles an hour. And we looked at our analytics and when we detected this pedestrian, and we detected the pedestrian 280 feet or about 85 meters detection capability. That's twice the distance you need to stop that car and save that person. There's been a lot of discussion about whether LiDAR wasn't on and the classification was difficult. All that said, if you had thermal on that car, you would have had twice the stopping distance capability of seeing and saving that person's life. We clearly see the pedestrian because they're living, and so they give off a lot of heat over the background. And that's the advantage, not only in night, but also daytime of thermal cameras. You get the ability to see live things that really jump out of that cluttered space. This is another example of going into the sun. If you think about autonomous vehicles, they have LiDAR and radar for ranging, and there is some sunlight that can glare and affect visible cameras. Because thermal cameras are passive and do not need any illumination, they use the natural heat of the environment of the people, we're not affected by sunlight at all. So glare conditions, nighttime driving conditions, all those kind of conditions, you just get rid of them if you're driving with thermal. So it's a really nice augmentation and redundant system to add. If anybody's familiar with Santa Barbara, this is State Street. Once a month, they have the cyclists go crazy and take over the streets. What you're seeing here is the ability to, again, see the people and the bicyclists jump out from the clutter and clearly identified. You also, on this side of the screen, might be able to see, sometimes there's some people as it moves forwards, that's kind of stuck between the palm trees and the poles. And again, because they're alive, they jump out, and you can really see these people. So as far as adding to the capability of an autonomous vehicle, you get this extra electromagnetic part of the spectrum you're seeing. It's passive, and it's amazing to see human things, live things move. This is an example in fog. There's another example of where we're passive, so we don't get a lot of diffusion, light scatter. You'll see a person over here near the stoplight, and see how they're highlighted because they're warm. A little bit further down the street, you're going to see two people walking down the sidewalk. Now, not only can you not see them in the visible, but if you saw this on radar or LiDAR that looked like sticks, which you're standing next to sticks. It could look like a tree. It could look like a pole. The key here is because they're live, they're giving off heat. If I'm in a car and I'm the analytics, I'm sitting there thinking, all right, there's some sticks by the side of the road. They're not going to move. I don't have to worry about them. You have to worry about the sticks that are going to move. The live things are going to move. They're erratic. They're humans. They're animals. And the nice thing about infrared is at night or in glare conditions or in fog, you're going to see them jump out, and it's the things that are going to move on you. You have to anticipate. The benefit that thermal brings is just in speed. We all like to get from point A to point B quickly. And if you've got a foggy condition like this, yeah, the autonomous car will get you there, but it's going to go 10 or 15 miles an hour because it can't see, and so it's not safe. With a thermal camera, you're going to be traveling at a regular speed because it can see, 200 meters down a road. We have a 200-meter detection capability in any lighting condition. So by default, it'll get you there from point A to point B as safely as possible. It's a great addition to an autonomous vehicle.
All right, so I'm still baffled by the fact that thermal is not completely ubiquitous in human-driven cars, let alone self-driving cars. So what is slowing or stopping its adoption? How much? I mean, a LiDAR costs thousands of dollars.
Correct. Tens of thousands.
Oh,
in
and
some
so
cases.
what does a consumer-grade thermal camera cost that might go into a vehicle equipped with ADAS?
It's usually less than $1,000.
So what's the problem?
The problem is some people feel that LiDAR is the necessary technology because of the situational awareness it provides. But they're starting to understand that thermal can provide another aspect to what's available on the road ahead and around the vehicle. And so it's starting to get to the point where many of the people that are developing autonomous cars are starting to think seriously about thermal.
Right. So when go ahead, Paul.
Yeah, so I was going to add on to what Stuart said. So, they're slow to adopt. They're having lots of challenges just driving in good conditions, in daylight, on the highway, and they're still having accidents. So it's this growing experience. Driving in a rural environment where you're going to see a lot of deer strikes, which cause $1 billion worth of damage a year, I think that people are now becoming aware. We're having a snowball effect from last year's CES to this year's CES on how many people are coming and are more excited about thermal. The other thing we're doing with the kit that we have, the ADK, is it's one thing to say, okay, we have a camera. It's another thing to say, let me put it on and collect data very quickly. we have to help them with that adoption. So what we've done with the 80K is we have a plug-and-play situation. You stick the camera on there. It's got a heated windscreen. It's encapsulated for weather. We have an SDK, and we have a thermal data set, because we've taken the time, and we'll talk about the analytics in a little bit later, to add on to that. But we've got this thermal data set annotated that people can take it, plug it into their analytics, and start driving immediately. So we have a plug-and-play opportunity for those people coming late to the game to get up to speed quickly.
Right, so integration is not the problem. Cost is not the problem. Is it just lack of awareness?
It can be packaging space too. Sometimes when you think about all the cameras and the lidars and the radars that are put on these cars that are running autonomously, sometimes it's just purely a space issue. But now with the technology delivered by FLIR, we can get the smallest camera possible. It used to be, it started off the size of, let's say, a baseball, and now it's down to the size of a sugar cube.
Exactly.
So it gets smaller and smaller, and that makes it a lot easier.
What I always find baffling, I mean, how many of you guys play video games? Someone here, right? Right? Not more people. This is CES. Anyone who's ever played a military sim, going back to, or tank-based sims in the 80s, the winning side always had thermal cameras. It's so obvious. If you know the history of modern armored warfare, what do the winning side always have? Thermal cameras. And if you play any first-person shooter, what's like the first thing you want to have? A thermal camera. So clearly, buyers in the automotive sector don't play video games. Am I correct?
It also has to do with the awareness. I mean, like I said, from last year's CES to this year's CES, we've had a lot more people coming up to us wanting to use our cameras. And unfortunately, whether we like it or not, the situation, the accident that we had in Tempe, we had just an avalanche of people coming and knocking on our door after that.
After that.
After that. Now, partly the reason we have the vehicle around the corner, and if you haven't had a chance to check it out, you should, is we're going to be driving that around, giving people test drives, and gathering more information like this to increase that awareness. I think Veoneer is doing a fantastic job of pushing thermal in the market space. They're the only one today that actually offers a camera for automotive use, night vision use. So between the two of us, we're just trying to work and get that awareness out there.
All right. You haven't done a lot of talking. Let's break down what Ansys does with simulation and thermal cameras. I understand it somewhat. Explain it to the crowd, because it's a complex topic.
Yeah, so simulation is essentially making computer models of everyday things. It could be a thermal camera, it could be a car, it could be a human heart, a rocket, anything. And running those computer models to get insights into how those things are behaving, so that those insights can be used in developing and designing those products. So for autonomous vehicles, for example, it's essential to test these vehicles for safety. And there are projections that people would need to drive autonomous vehicles for literally billions of miles. And that's simply not possible. It would take 100,000 hours or 100 years or so.
Well, sorry to interrupt. I know that Waymo has their own simulator. Different OEMs have their own simulators. And that their simulators, when they're built in-house, are designed only to simulate the hardware that they're using and the software that they're using. And are you the only ones who are built a simulator that can simulate thermal cameras in the simulation?
That's correct. We focus on physics-based simulation. So the world runs on physics. And if we have to simulate how things are going to behave in the real world properly, we need to simulate that physics. And we do physics of all kinds. And we do physics of thermal cameras, for example. So you see some imagery over here. We do simulations. On the top left, you see simulations of cameras. This is actually supposed to be animations running. Those cameras, we do optics, how light is going to pass through the camera and what images are going to be created. And on the right-hand side, we see simulations. So this is simulated drives. This is a virtual environment where you can drive miles and do virtual tests. So we always say that if the accidents like you saw earlier in the video were to happen, they should happen in a simulation and not in the real world. Because, who cares if a car hits a pedestrian in a simulation? So that's what we do. We do physics-based simulation. So we're able to predict with high accuracy how things are going to look. So here you see comparisons on the left-hand side of a visible light RGB camera, and on the right-hand side are imagery in the same simulation scene coming from the FLIR camera. And we can do many variations, like test different types, different levels of fog. And you can see in those simulations that the visual camera cannot predict or cannot see the pedestrian in fog, whereas the thermal camera can.
So I'm curious, again, about the testing of self-driving vehicles, because these numbers of miles that, in real-world miles, you need, in theory, to deploy a safe car, and no one knows what safe is, and then the number of miles you need to drive in simulation are vast. So if a company comes to you and says, we will need to install thermal cameras in a fleet of 85 cars, and then they come to you and they want to integrate them, they still need to figure out how to test in simulation. So do you provide, they're not starting from scratch.
Right.
So what do you provide them to accelerate the process? Because Rand Corporation, I forget what the number is.
Yep.
It's billions and
billions
billions.
of miles,
Okay.
yeah.
So there are companies out there now that already have some billion miles of simulation miles.
Right.
If you want to catch up, what do you do?
Yeah, so we give simulation software. First of all, the software is a key intellectual property. We have been developing it for decades, and that software physically predicts what the sensors are going to see. So that's one piece. But we also work with customers like FLIR for setting up the processes for doing those simulations, for taking the data from the vehicles, virtualizing it, and then running scenarios many times over by making variations. So you saw some real-life videos. We could take a video like that, build a model, and then vary many things on it. Vary the density of fog, vary the speed at which vehicles are traveling, put more pedestrians, change their temperatures, whatever you want very quickly.
So the bottom line is, by capturing a few thermal images that we've got already in our library, we've got 14,000, we can actually validate the simulation and cross-reference it, and then we can use the simulation to get tens and tens or hundreds of thousands of miles under our belt in a simulator. And it's the computer, I know it's scary, but it's the computer teaching the computer, and it works really well. And if you know anything about the analytics or AI, this is the way it's happening today. And you can get from point A to point 0 to 60 miles an hour very quickly in analytics. You just need a little bit of a thermal data set start, which we have, and we made it available to people, and then you leverage the use of an analytic to get you the rest of the way there. And you catch up very quickly. You don't need millions and millions and millions of miles. You can get there very, very quickly if you use some simulation.
Stuart, sometime in the late 90s when the first thermal cameras went into luxury cars,
Yes.
it seemed like they were priced not, how do I put this? Without insulting anyone, they were priced as kind of a luxury option that you bought for fun because, like me, you just had to have the cool thing for a very unique use case.
Yes.
Sometime in the early, 2000s, they seemed to go away for a while. And then because of self-driving cars, the discussion has returned. And even before we spoke, I started to see people say, well, thermal cameras really should come back. How long before we see a real market penetration, if not ubiquity, of thermal cameras on vehicles?
Yeah, but first of all, they never really went away. You know, it was kind of a slow growth of the business. Originally, we thought it was going to grow astronomically, but in reality, it was a slow growth. And
Because BMW had one in like 2004.
BMW had one.
Cadillac has
Mercedes,
one now.
Cadillac has one. They had one. The Cadillac was actually first in 2000. So we grew into all the German luxury vehicles. So BMW, Audi, Mercedes, VW, Porsche. Then we went into very luxury, ultra luxury cars like Rolls-Royce, Bentley, and now we're in more of the mid-level cars. We're in PSA, Peugeot vehicles, Citroën vehicles, Cadillac vehicles, and you'll start to see the price come down and down, down. So for normal cars, passenger cars, not autonomous cars, it's going to eventually grow, and it'll probably grow slowly. As the price comes down, the penetration will definitely go up much higher. But now with autonomous vehicles, it's really important. It's a key element. There has to be redundancy in autonomous vehicles. You can't just have a LiDAR. You can't just have a radar system. You can't just have a visible camera. You need multiple sources of information, and that's where thermal's going to come back in. So as autonomous vehicles start to become a real reality in the world, we'll have to have technology like thermal to actually make sure that they're safe and we can prevent the kinds of accidents that happen in Tempe.
Paul?
I just want to add one additional thing a lot of people miss, and I think there will be traction. I think we're a few years out, because in anything in automotive, it takes a few years by the time you get tested, validated. But one thing you have to be aware of is, right now, LiDARs are expensive and they're struggling to shrink them down.
And they're so far incapable of delivering an inexpensive solid-state unit,
Correct.
right?
Yeah, it's going to take some time. Yes, correct.
But think about the challenges of that. You're trying to get a lot of points on target, a lot of energy down the road so you can see 200-300 meters, and you're trying to shrink it. When you think about what the combination of a high-resolution visible and thermal sensor can do, at that point, maybe you have enough sensing and perception to where you don't need as many points on target from a LiDAR system. So maybe adding a few $100s for a thermal sensor will enable you to shrink your LiDAR and not put as much cost and effort into that LiDAR. So you may actually end up, and it may be the tipping point for thermal, if people take a look at the overall system use case and cost, redundancy, capability, but the fact that it may be cheaper to add a thermal sensor than it is to fight some of the LiDAR constraints that you have, that might be a bit of a tipping point for us in the industry.
Well, I could go on and on, but my questions are all about how to commit crimes in cars and have nothing to do with safety. So we should go to questions. We're not taking any questions about the Cannonball Run at all. Would anyone like to talk about LiDAR versus thermal? Really, no one has any questions? I can't hear what this gentleman's
I think
saying.
he's saying only thermal camera. Do you have a mic?
Why? Because when you use radar and lidar, you have like microgal. If you think about many cars drive with radar and lidar, you feel like inside microgal. Think about it. And use thermal camera, it's passive, not nothing. With the like radar and lidar was could make me sick.
I know exactly what you mean. In fact, one of the things I noticed, I was driving a Cadillac with Super Cruise recently, and there was a night vision camera in the car. It's one of yours.
Yes, it is.
I hope so. Anyway, what I find fascinating about the thermal camera in that car, first of all, is that the display is center mounted in the dash. And because it's a passive sensor, it requires no interpretation. It sees a person, I know it's a person.
Right.
If a vehicle has a LiDAR on board or a radar, the human driver, the human eye, cannot interpret the data coming in from those sensors. But give me a screen with a thermal camera, I know exactly what I'm looking at, even without bounding boxes or any other identifiers. So I would want that on any human-driven car today.
Yep.
And I just don't understand why it's not a standard option.
Sometimes it's interesting. You don't know what you don't have until until you see it. I drive a lot of thermal cameras in cars. I do a lot of testing. And we have a university around the corner from my facility, UCSB. I call it a target-rich environment because the students ride skateboards and bicyclists, and they have no fear whatsoever. And once you've driven a thermal camera in a car around that facility and you see everything, and how the idiots are going to zip in front of you. And then you drive a car without it, you realize how scary it is not to have it and how many people you almost just hit. I go about 20 miles an hour slower in a regular car around UCSB because I'm terrified I'm going to hit my daughter. That's what it is.
One of the other interesting things I found, and are there any Tesla drivers in the audience? Okay, so I'm a big fan of Teslas, but whenever they talk about the minimum requirement in terms of sensor hardware to get to full self-driving, or even, in my opinion, the minimum sensor requirement for safe human driving, they're relying on two sensors, radar and camera. And so when you look at the rest of the industry, they're adding LiDAR. So you have three sensors. If one should go bad, you don't have sufficient quorum for the vehicle to continue driving under any form of automation. And even if all three are working, it seems very obvious to me that the sum total of them is not sufficient for me to feel safe with a car driving in an automated manner. And that the supplement of a thermal camera is essential in case you have a failure of one, if not two sensors, which happens. And the ultimate use case is that level 5 vehicles, go anywhere, drive anywhere, cannot possibly ever arrive unless they work in winter conditions, where thermal cameras have a unique advantage over any other. So has anyone ever done a study, or when you go out to market with marketing materials indicating, say, the history of military conflicts of forces lacking in information? They always lose. Always lose. Does anyone else have any other questions about thermal cameras? This gentleman. Wearing a military hat, an unfair advantage. We use sniper? Go ahead.
Is there any plans for a consumer-based model for a thermal camera to add on to like mid-range cars, like not super luxury, but like so existing cars are already there, so we can have like an aftermarket? There we go. Yeah.
That's a great question. I love that question. That's a question that speaks directly to me.
Yeah, FLIR actually does make an aftermarket version of the camera. It's called Pathfinder.
Right. So we sell a solution to Autoliv, and they put it in BMWs and Audis and Peugeot. We sell the same thing as an aftermarket. So you don't necessarily have to go buy a BMW. You can buy something called a Pathfinder, Pathfinder 2, and you can plug it in your car, and it's exactly the same.
How much does it cost?
It depends where you buy it from.
How much would it cost this man?
It's probably going to cost them about just less than $2,000 for a full install.
And
Now, that's not cheap, but again, depending on how you're going to use it, it could be amazingly safe. Anybody who drives in a location, you can get the insurance map. You might actually be able to work with the insurance company and get reduced rates. There's certain areas of the country where deer strikes are very prevalent, and this thing will pop on deer and identify them like crazy. So, deers cost, $1 billion worth of damage, I think.
Yeah, actually, there's about $3.5 billion worth of damage every year based on cars hitting deers or other objects at night.
So if you live in that area, you might be able to go to your State Farm office and say, I have a thermal camera to reduce my rates. I'm not going to hit a deer.
So can the Pathfinder be installed by the average customer, or does it require going to an aftermarket shop?
You can do both. It depends on your level of ability. If I was to give it to my daughter, I'd say no. If I was to give it to myself or my brother, I'd say yes. It depends on your ability with a screwdriver. Most people I know would be able to install this thing. You plug it into 12 volts. The only difficulty is you got to plug it into a screen. An aftermarket installer can do that, but if you feel comfortable, just plug it into your dash monitor. You're okay with that, you can do that.
And the camera, the Pathfinder aftermarket camera, does it go on the front bumper and then you run a cable into the car, or does it go on the dash and link to a screen?
So one of the downsides to thermal cameras, I'll just say downsides is a small downside, is the fact that you cannot actually see through the windscreen. You can't see through glass. So you have to mount it externally. If you notice on the car outside around the corner here, you can put them on the roof for autonomous vehicles to get a good field of view. Typically what we see with a Pathfinder and we see in OEM installs, they install it in the grille. So it's in the forward facing of the car. Audi has probably got one of the nicest integrations. They use the 4 rings and they put the camera in one of the rings. It's really a nice implementation.
And Cadillac is also very nice. You can barely see it installed in that vehicle.
And some of the newer cameras, to your point, when you did the Cannonball, it's the size of your fist.
It was actually more like half a shoebox.
Well, now it's about the size, as Stuart said, of the sugar cube. A little bit bigger if you put an enclosure on it. So it's very easy to actually install.
Any other questions? This man.
Thank you. Hi. My question is actually, the thermal cameras, they definitely have clear advantages over optical cameras, right? I mean, where optical cameras fail, thermal cameras are giving you a lot of advantages. But, I mean, the price, is it the technology barrier? Because your price is so high, it's $2,000 or $1,000 for one camera, when for $50, one can buy an optical camera.
Oh, you can buy an optical camera for $50.
Yeah.
But it's not going to do what...
No, but my question is how you're going to address that.
Okay. So when you talk about the technology, we started off, you're talking about an 8 to 14 micron wavelength. So you can only shrink the pixels so much. So what we've done is we've from when Alex was driving, it was about a 50 micron pixel. We've got that down to 12 micron. We're looking at going smaller. So we're shrinking the actual sensor size, and with volume comes cost reduction. And so far, we're kind of on this curve of being able to drive our prices down to meet the market need. If you take a look at a LiDAR system, it's a lot more expensive than a thermal camera. They talk about bringing that down significantly in volume. We have a lot less to go, and we will be able to achieve that when we get those volumes. It's all about shrinking the technology, and FLIR's at the forefront of that, and it's all about volume. With more volume comes cost. So as we see a greater adoption, the price will come down, and it'll be the vicious circle of more volume, lower cost. It'll work to everybody's benefit.
I always like to say, sorry, go ahead,
Well,
Sandeep.
one comment I want to make is this is really a system optimization problem. We can't think of single sensors in isolation. We have to think of the whole suite of sensors and choose the whole suite of sensors that's best for the system to perform for what it's supposed to do. So we have to look at a system which has multiple sensors and optimize that for whatever cost or performance that you want to optimize it for. We do this in simulation where we have a simulation running with a car with all different kinds of sensors, radars, LiDARs, cameras, thermal cameras, and we can actually optimize the system to see which type of scenarios are captured by which set of sensors and what cost it would give. So we have to do that as a system level problem.
But let's use your example. When Kodak first came out with a CMOS camera, tens of thousands of dollars, big honking sensor, right? Now it's what, 10, 15 bucks, and you can get in a cell phone. That'll happen with thermal. It's just going to take the volume, and that'll happen in time. It depends on he asked how long. It's going to depend on the adoption. If Stuart at Veoneer decides they want to buy 5 million cameras tomorrow, everyone's price is going to come down.
We're working on it.
Yeah, we're working on it together. That's the goal. The goal is to get the volume, to drive the price down, to increase adoption, because we want to save more lives. We don't want another Uber accident to happen. That's a solvable problem. Our mission is to save lives and livelihoods in FLIR. We want to get this thing to market.
Well, it's funny because actually that problem was already solved because FLIR existed. And an optical camera at any price will never do what a thermal camera can do at any price. The world's greatest optical camera will not function in certain lighting conditions, in certain weather conditions, and a thermal camera will. And I hate to close on this, but the average casket costs $3,000. Think about every single person who's ever lost someone in a car accident. How much would they spend on a thermal camera if they knew it would save the life of someone they lost? Way more than $3,000. Yep. And sure. At the cost of what? A few $100s for an OEM volume, every single car on the road could have one of these cameras. Yep. Would anyone else like to ask a question? Because we should wrap it up before I get kicked off stage. This gentleman.
Are the cameras subject to snow buildup? Like if you're in the north and you install it on the grill, sometimes my backup camera gets all cloudy and stuff like that.
Yeah.
So
Now we've designed a window heater into the front of the front lens of the vehicle of the camera itself, and it keeps the snow and ice off of it.
Yeah, it actually does a really good job. It's built into our dev kits as well. So Veoneer offers this as an option on their OEM cars, and we built it into our test vehicle and our ADKs, our auto dev kits. Same reason. You want to drive in all-weather. The purpose of this camera is to drive in all-weather conditions, so we designed it, and Veoneer designed it, to drive it in all-weather conditions.
And I can vouch for that. I've had my Gen 1 FLIR camera on my BMW bumper for 15 years. And it's never failed in New York City. So, are we all cool for questions? Anyone else? Well, thank you so much for coming. This is
One more.
this man.
Is there any kind of regulation considering the sensor of autonomous cars, so one can suggest that thermal camera will be in
I think it should be mandatory, but go ahead, answer the question.
You're talking about regulations regarding thermal sensors? So thermal sensors...
regulation considering sensor as a part of the safety.
Oh,
Thermal
that's actually...
might be an answer, but
So that's actually an interesting question. So the question was, is it going to be actually regulated? Like the auto emergency brake was regulated, the backup camera was regulated. We're talking to the IIHS right now about some of the new tests that they're doing. One of them is people walking out from between cars and different lighting conditions. And so they're looking at that because if there's something that really tests the suite of sensors today, is a person walking between cars. A visible camera, if you're wearing dark clothes against a dark car, really doesn't see it. A radar gets confused, a LiDAR gets confused. Because it's a human being, the thermal camera sees it as highlighted. It's a real lit thing. It's very easy for the analytics. So we're actually talking to the IIHS and other institutes to see if we can get some kind of regulation going.
Yeah, and to get 5-star ratings for cars in about 2022, to be able to see pedestrians at night, you get higher ratings for doing that. So some things like thermal will help achieve the 5-star ratings.
So actually, I have one more question in that direction. Euro NCAP has stated that a driver monitoring system will be mandatory to get a 5-star rating. So have you seen more traction with Euro NCAP glomming onto the necessity of thermal than, say, American agencies?
I think Stuart just kind of touched on that. I think the European...
Yeah.
They'll be first?
Yeah.
No, actually, they're kind of going hand in hand at this point, and they're both pushing for better regulations at night for pedestrian safety.
Cool.
Good question.
Oh, this gentleman right here. Oh, he looks like a cannonballer. Take the mic away from this guy.
Why?
I can tell.
So if I spend $2,000 and put a Pathfinder on my car, what's the expectancy of life on it? In 5 years?
At least 15 years, based on my experience.
Yeah.
How long is it?
It's at least 10 years, if not longer. You're going to definitely get the use out of it. I mean, if you just, to your point, you're either going to save a life or you're not going to hit a deer in certain places. It'll kind of pay for itself pretty quickly.
You could drive as fast as you want and see police at least a mile away.
But we've been shipping in cars for Autoliv now Veoneer since 2003, I think, was it? 2003?
2005.
2005. And also we've been shipping Pathfinder 1, the first version of that, since about the same time frame. And we still have them on the roads. As long as the car is working, the camera is working. It's an extremely reliable technology. One of the things FLIR and Veoneer they really taught us how to do this, was to embed the quality in our camera systems to automotive quality to last that length of time. That's one of the reasons all the products on here on the FLIR stand benefits from that automotive quality, because that level of quality goes in all our products, not just automotive.
Yep. And if you use Waze by radar detector, you can drive as fast as you want. Last question. You were good? All right. Thank you so much for coming. Stuart, Paul, Sandeep, thank you so much for coming.
Alex. Appreciate
Thank
it.
you so much. Thanks.
Thank you, guys.
Thank you.
Thanks, Alex. Thanks, Stuart.
Thank you.
Thanks, Sandeep.